The next structural member is beam. This is the cross section of the beam which has breadth and depth. So here we are having length, breadth and depth. So these three are the important dimensions of beam. Here this beam is supported by column. The distance between column to column is clear span. The distance between center to center of the column is called effective span. So let's look into the thumb rule for beam depth. To find out the beam depth, we have thumb rules. First one is L by 12 to L by 10. Second one is depth is equal to 1 by 10th of length. That is, if we want in millimeter, we have to use this formula. Depth is equal to 1 by 10th of the length. Another thumb rule, if the span is given in feet, the measurement of the span is in feet, then we have to use this formula. That is, 1 feet length is equal to 1 inch depth we need to consider. So here the length indicates the clear span. In this formula also the length indicates the clear span. Consider the clear span as 5000 mm and thumb rule for beam depth. Let's use the first formula L by 12 to L by 10. 5000 divided by 12 to 5000 divided by 10, which comes around 416 to 500 mm. So let's consider the depth as 500 mm for this case. The second thumb rule is depth is equal to 1 by 10th of length. Here the span is in millimeter. So 7000 is the length. So how much depth we need to consider for this 7000 mm clear span? So that is 700 mm. Depth is equal to 1 by 10th of length. Next let's have the clear span as 15 feet. So let's use the thumb rule. 1 feet length is equal to 1 inch depth. When the measurement is given in feet, we have to consider 1 feet length is equal to 1 inch depth. So here the length is 15 feet. So we need to consider the depth as 15 inches. Now we know how to find out the depth of the beam using thumb rule. What about the width of the beam? How do we find out the width of the beam? Width of the beam will mainly depend on the wall thickness or thickness of the column. So wherever the main walls are there, like 9 inch or 8 inch walls, there we have to use the 9 inch or 8 inch beam width. And similarly, where the partition walls are there around 4 inch or 4.5 inch walls, there also you have to use the same beam thickness, beam width, that means 9 inch or 8 inch. But if there is a partition wall, the projection will be seen inside the room. The beam projection will be seen inside the room. Let's see, as per IS 13920 2016, IS 13920 is the code which is used for ductile detailing. What is the condition given for width of the beam? If you see in class number 6.1.1, the beam shall preferably have width to depth ratio of more than 0.3. So this is the one condition. Width to depth ratio shall be more than 0.3 and the beam shall not have width less than 200 mm. Always we have to use the beam width as minimum 200 mm. It may vary, like 225 we can use, or else 300 also we can use. It's according to the type of structure and what is the load coming on the structure. It all depends. So but minimum we have to use 200 mm. Here the clear span is 5000 mm. So our depth is 500 mm and minimum width I took as 200 mm. We know breadth and depth of the beam now. Let's see the breadth to depth ratio, which is coming around 0.4. So this condition is satisfied. Beam shall preferably have width to depth ratio of more than 0.3. So ours is 0.4. It is more than 0.3. So then it is satisfying this condition. So friends, that's all about how to choose the initial size of the beam. Let's meet in the next video.